In today's video, we're going to be computing a very interesting limit, and that's the limit as x tends to infinity of x squared plus 1 all over x squared minus 1 all that raised to the power x squared. So generally, once we're given limits of this form, we need to transform them to look like a standard limit, and the standard limit known to us is the limit as x tends to infinity of 1 plus 1 on x all that raised to the power x equals to e. So you have to memorize this formula. So let's proceed with our simplification. We have our limit as x tends to infinity of, we can simplify this as x squared all over x squared minus 1 plus 1 all over x squared minus 1. All of that will be raised to the power x squared. Then we proceed by introducing a variable. We're going to call that variable n, and we say let x squared minus 1 be equal to n. And the reason I do this is for us to have a general view, or to easily see how it relates to our above standard limit. So having this in mind, this implies that x squared will be n plus 1. Then we're going to call this equation 1, and we're going to call this our equation star. So putting equation star in 1, putting equation 1 in star, we have this. So this time around, we're going to have the limit as n tends to infinity, because as x tends to infinity, x minus 1 will equally tend to infinity. So n will tend to infinity since x squared minus 1 is n. So this will be equivalent to x squared is simply n plus 1 divided by x squared minus 1 is n plus 1 all over x squared minus 1 is n. All of that raised to the power x squared, and x squared is n plus 1. So this, we can further simplify it by simply doing this. So this is the same as n on n plus 1 on n plus 1 on n, all that raised to the power n plus 1. And further simplify, we have the limit as n tends to infinity of 1 plus 1 on 2n, all that raised to the power n plus 1. So if we look at this very well, it's already similar to this, but not exact, because in the denominator we have a single variable, but here we have a variable multiplied by a constant 2. So we'll look for a way to transform it, and to transform that, before even transforming, this can be written as the limit as n tends to infinity of 1 plus 1 on 2n, all that raised to the power n, times 1 plus 1 on 2n, all that raised to the power 1. This is basic laws of indices. So having this in mind, we're going to introduce the third, or let me say the second variable, and that variable we're going to call it m. So let 2n be equal to m. This implies that n will be m on 2. We're going to call this equation 2, and we call this equation double star. So putting equation 2 in double star, we have, so anywhere we see our n, we replace it with m on 2, and anywhere we see 2n, we replace it with m. So doing that, we're going to have the limit as in this time around, m is tending to infinity, since we know that as m tends to infinity, m on 2 will equally tend to infinity, because dividing infinity by 2 will give us infinity. So it will still be the limit as m tends to infinity of, here we have 1 plus 1 on m, all that raised to the power n. N is m on 2 multiplied by 1 plus 1 on m, all that raised to the power 1. So having this in mind, we can easily compute our limit now because this looks exactly like the one above. But before that, there is a single step we can do. If we notice this formula here, as m tends to infinity, 1 on m would tend to 0. So this will be 1 plus 0 all that raised to the power 1. So this will tend to 1. So we don't have to bother about this particular formula. So our interest will lie on this. So we can write this as the limit as m tends to infinity of 1 plus 1 on m, all that raised to the power m, and all of that raised to the power a half. This will look exactly like the standard limit that we have above. So we can easily replace it with e, and replacing that, we have the this will be e raised to the power a half, which is equivalent to the square root of e. So that's our limit. Okay, thank you very much for watching, and see you all in the next video.